All right, guys, so it's 5 o'clock. Let's get started on this. So it's Tuesday today, so that means we're doing paper 1. Today, we are going to do some work around sequences and series. The first question, oh, sorry, I beg your pardon. Sorry, Hugo, you're quite right. So Yolenda's not with us this evening. So Hugo is standing in. So a big warm welcome to you, Hugo. Thank you so much for standing in for Yolenda. And we certainly will call on you if we're experiencing any difficulties. And sometimes you may have to assist some of the learners just if there's things that they don't understand, etc., etc., if I'm busy explaining something else. So thank you so much, Hugo. Really appreciate your assistance this evening here in our grade 12 class.
Thanks.
Okay, so
That
oh, good. Thank you so much. All right, everybody. So let's get cracking and let's have a look at the first couple of questions. The first two are very, very, very simple. So this is just to warm up our brains before we get into the sort of slightly more difficult work. So if they give us an nth term, 3n minus 1, and they want us to write down the first 3 terms of the sequence, how would we do that? What would we get as an answer? What would you say? Can anyone tell us what they think the first 3 terms in the sequence would be? %. So you'd be subbing 1 and then 2 and then 3 into your formula. You're quite right, Amatle. So if we subbed in 1, we would end up with the answer of -2. That would be our first term. If we subbed in 2, we would then get a second term of 1. And if we subbed in 3, we would get a third term of 4. Does that make sense to everybody? That's it. I'm getting the same answers. All right, nice and easy. And now they want us to determine the sum of the first 50 terms of the sequence. So is this an arithmetic sum or a geometric sum? Indeed. Okay, so it's an arithmetic sum. Good, well done. There's a constant difference, not a constant ratio. So we would set it out as follows. So we would write there the sum to 50 is equal to 50 over 2 into 2a, which is -2, plus n minus 1 times our difference. And in this case, our difference would be 3. Oopsie daisy. And we can pop that in. What are you guys getting as an answer? Maybe, oh, I see what I did wrong. Okay, good. I got a different answer from you, but now I understand why. Yes. I did something silly. That's it. Well done, everybody. Yes, Cheslin, good, Lebogang. We would get 3, 5, 7, 5 as our answer. Okay, so I'm not sure why they allocated 2 marks over here. I imagine you'd probably get 2 marks for all 3 correct. Good, Segofat, so that's perfect. And here there would be a method mark for subbing into the correct formula and then a mark on our answer. Okay, so that is the easy question over and done with. This is going to be a little bit more difficult. Okay, so in question 2.2, they tell us that 5 over root 3, 5 over 3, and 5 over 3 root 3 are the first 3 terms of a geometric sequence. The first thing that they want us to do in question 2.2.1 is they want us to determine the general term Tn of the sequence. Okay, so again, we've got to use the correct formula. So if I go up to the top here where my formulae are, which is the correct formula to use? Can anybody tell me? middle, bottom, says Gugu. So in other words, Gugu, are you saying I must use this formula? Is that the right one? Okay. Mikhail, take your screenshot quickly. I'm just going to go down to the question again. Oh, you changed your mind, Gugu. That's okay. I know it's difficult when the screen is going up and down and you don't have the questions in front of you again. So for question 221, determine the general term Tn of the sequence. Which one is the correct one to use? The one on the left. No problem, Mikhail. There we go. Okay, so it's going to be this one over here. Okay, this is the correct formula to use that I have drawn the blue circle around. I'm not going to use this one over here. This one is not the correct formula because this is for an arithmetic sequence. Okay, so this is an arithmetic Tn. This over here is an arithmetic Sn. This over here with a blue ring around it is your geometric Tn. The one in the middle that we originally identified, that is your geometric Sn, and then remember this one over here on its own to the right hand side is your sum to infinity. Okay, so bottom left is the correct one. Okay, so the reason why it's so important that you know which is the correct formula to use is because if you sub into the wrong formula, you're not going to get any marks at all. Okay, so you've got to use the correct formula for what it is that we are working with. Okay, so we want this one over here in the bottom left-hand corner, Tn equals AR to the n minus 1. That is our geometric Tn formula. Okay, so you don't have to write the formula down. You can sub just straight into the formula, but I'm writing it down just to make it easier for everybody. Okay, so if they want us to determine the general term, what they're really implying is that we need to know the value of A and we need to know the value of R. A is easy, it's given to us. Remember, A is the first term in the pattern. So that would be 5 over root 3. Sorry, that's a horrible root 3. And I'm just going to put that in brackets because it's fairly nasty. What I'm going to need now is my R value. Okay, so remember, R is calculated by dividing term 3 over term 2 or term 2 over term 1. Let's see what you guys are saying. Root 3 over 3 says Nhlanhla. Zehofatso also says root 3 over 3. So this is something we can do on our calculator. Remember, like last time I said to you, rather than working with complex fractions, a fraction over a fraction, rather just say 5 over 3 root 3 and use the old-fashioned divide sign and divide that by 5 over 3. Okay, are you guys getting the same answers as Zehofatso and Nhlanhla? I certainly am. Good, well done. So in other words, we said 5 over 3 root 3 divided by 5 over 3, and I get the same as what you have both said as well. I'm getting root 3 over 3. So over here, we've got root 3 over 3 to the power of n minus 1, like so. Okay, so there would be a mark here. It's out of 2. There's going to be a mark for subbing into the correct formula. A is given, so I think the other mark here would be on the correct R value. Okay, am I allowed to multiply these two values together, the A and the R? Can I multiply them together and simplify that? Is that allowed mathematically? Okay, so Gugu, You've said no. Kalipa said no. Lebogang said no. Perfect. You are all correct. Okay. I cannot simply multiply those two numbers together, and that's because of the exponent, the n minus 1 on the value of r. Remember, the only time that we are allowed, so the people in boot camp would have seen this, the only time we are allowed to multiply two bases that are different to one another with each other is if the exponent is the same. So in other words, if I have a situation like that, because my exponents are the same, then I am allowed to multiply the bases together and keep that exponent. Okay, but that is not what is happening in question 2.2.1. Okay, so now question 2.2.2, they want us to calculate which term in the sequence will have a value of 5 over 243. So again, I'm not going to say what it is that we should do. I'm going to invite suggestions from you guys. What do you think we should do with this number, this 5 over 243? Oh, excuse me. I'm sorry, Trix, I keep sneezing. What do you guys think we should do with that? So some nice suggestions coming through from you. Sub in TN and solve for it. Good, and Mbalendle, put it in place of TN. Thank you, Gugu. Equate to the general term. Quite right, Nhlanhla. Make it TN, says Amatle. Equate the TN, says Sehofatso. Yes, and Randy says make it the TN. Good, well done. All right, so we're going to go ahead and go and do exactly that. I'm just going to move this down a little bit. So we're going to take our 5 over 243, and we're going to make it equal to 5 over root 3. And here we've got our root 3 over 3 to the n minus 1. Okay, so I've written the first line, okay, based off of what you guys have said, which is correct. I would like you to try and solve for n. And then you can either DM Hugo or you can DM me with your answers. And we'll talk about this again in about 5 minutes. I want you just to try this on your own. I'm just going to move this down. That was anything but. Sorry, guys. Okay, so remember in this question, it says which term in the sequence. So remember, when a question says which term in the sequence, the words which term mean you are solving for the value of n. I'm going to let you guys try this. Okay. Okay, Nhlanhla. Good, Lebogang. Yes, nice. You and Nhlanhla have got the same answers. That's great. That's it. Tristy? Yeah, no problem. Tristan. Oh, sorry, Tristan. Sorry, Tristan. Okay, good, Cheslin. Good, Tristan. Perfect. Tristan, Cheslin, Lebogang, and Nhlanhla, if you want to start looking at the next question, which is 2.3, you're welcome to continue with that. Well done, Gugu. Gugu, you can also carry on with question 2.3 now. You guys should be able to do 2.3.1 without any difficulty. How's everybody else doing? Okay, so I'm just going to wait another couple of minutes and then we're going to do the answer to this. Okay, Tristan. So I got the same answer as you. Yes, Gugu, well done. I got the same answer as you. Okay, cool, Chadwin. Thank you so much for sending through your answer for 2.2.2. Awesome. Good stuff. Okay, so let's go and have a look at how we would do that, and then we can certainly carry on with question 2.3.1. Those of you that haven't had a chance to try it can try it, and then we can have a look at how we would do 2.3.2. Okay, so what do I need to do to both sides of my equation here? So after my cracking my first line, what's the next thing that I want to do? Can anyone tell me in 2.2.2? Okay, thanks, Gugu. All right, so Gugu says divide by 5 root 3. So in other words, what Gugu is saying, Amartle says divide 5 over 243 by 5 over root 3. Absolutely. So we're dividing both sides of our equation by this value over here, which is the coefficient of our base. So I'm going to take 5 over 243 and I'm going to divide it by 5 over root 3 because I want to isolate my base. And of course, when I divide fractions, I know that I have to tip in times. So that gives me 5 over 243. And now I'm going to multiply that by root 3 over 5. And it's going to be equal to root 3 over 3. Sorry, I'm not writing that very neatly. And then what I'm going to do is I'm going to come and work over here. Obviously, you would continue working underneath. So I've got a 5 at the top, which I can cancel with a 5 at the bottom. And then this would leave me with root 3 at the top over 243, which is equal to root 3 over 3. And that's all raised to the power of n minus 1. Okay, so now that I've got to the step over here, sorry, I shouldn't have an equal sign over there. Now that I've got to the step over here, what is the next thing that I need to do? Okay, so you guys are saying I can use logs. All right, that's fine. Okay, cool. So when using logs, okay, so Lebogang, you did a different way. You made the 243 into 3 to the power of 5. Okay, and then how did you deal with it after that, Lebogang? We'll do both solutions. So we've got root 3 over, and then 243 you've written as 3 to the power of 5 is equal to root 3 over 3. What did you do next, Lebogang? If we did logs, we would say our exponent, which is n minus 1, is equal to log base. So our base is root 3 over 3, and then we would put our number over here. So root 3 over 243. Okay, so when we go and put that log in, we'd get root 3 over 3 is equal to, and then here we've got root 3 over 243. We'd get 9. Okay, cool. So we've got 9, n minus 1 is equal to 9, and therefore n would be equal to 10. Beautiful. Okay, so Lebogang, you said you took it to the top. So in other words, did you end up with root 3 times 3 to the power of negative 5? Yes, okay, that's fine. And then over here, you've got root 3 times 3 to the power of negative 1. And that's raised to the power of n minus 1. Then what did you do? After that, Lebogang? because I'm just looking at what we would do here as an alternative method if we weren't going to use logs. It just seems as though it might become a little bit difficult for us. Because, oh, you know what I think we could do here? Do you know what I think we would end up doing? This is why I was asking you what it is that you did, Lebogang, but I think this is what I would do, is I would rewrite root 3 as 3 to the power of a half. And then here you've got 3 to the power of -5. And then here, this is your base. You've got 3 to the power of a half times 3 to the power of, sorry, that's -1 to the n minus 1. And then you could say, when I multiply like bases, I keep my base and I add my exponents. So this is going to give me -4.5, which is 9/2. And over here, this is going to be 3 to the power of -1/2. And then that's got to be raised to the power of n minus 1. Oh, okay. So you can't cancel the thirds because this third over here is part of your base. So the only thing that you could do if you didn't use logs is obviously quite a bit quicker. You see your mistake. Okay, and then you would continue to solve, and you'd end up with the same answer eventually. Okay, but you would have to write that root 3 as 3 to the power of half. Do you want me to finish this solution over here? You got 30. Okay, well, we shouldn't be getting 30. Is that a different answer, Gugu? Is that for 2.3.2? Oh, okay. All right. I was going to say, I thought you were saying it for this one over here. And I was like, no, it should still be 10. Okay. So everybody, as an alternative, if you didn't use logs, which clearly is the probably the easiest thing to do here, but you don't have to do it this way. So the important thing, if you're going to do it by making the bases the same, you've got to write 3 as 3 to the power of a half, and then say, when I multiply like bases, I add my exponents. Okay, so that means we've now got 3 to the power of -9/2 is equal to 3 to the negative half n. So remember, we raise a power to a power, we multiply our exponents, and then this would be plus 1/2. And now that your bases are the same, we can equate our exponents. So that means I can equate -9/2 is equal to -1/2n plus 1/2. I can multiply everything by 2, so I get -9 is equal to -n plus 1. And now if I swap the n and I put it on that side, and then on this side I've got 9 plus 1, so I'd get n was equal to 10. Okay, so you'd end up with the same answer. Okay, so either you can use logs, or if you wanted to make the basis the same, it's a little bit more difficult, but you could do it that way as well. Okay. All right. So let's have a look at the next question over here. Gugu, you've already got an answer for question 2.3.2. So question 2.3 is on quadratic sequences. Again, I'd like you guys to do 2.3.1 on your own. And let's see if you can do 2.3.2 on your own as well. Gugu, I'm just going to try and move. Sorry, I left my mouse at school, which is so irritating. I hate teaching Watobe without having my mouse. Can I move this up a little bit? Okay, I'm just going to do that. There we go. And then we've got both on screen. Okay, so if anybody else has finished 2.3.2, you can go on to the second question 2. Cool, Cheslin. Well done. Oh, yeah, mark allocation. Sorry, Gugu, you're quite right. Sorry. How much was this out of? Come on. It was out of 4. Okay, so there's obviously got to be a mark on the answer. There's going to be a mark on this line where you used logs. That would be the same as this line over here where you made the bases the same. There's your mark on your answer. There has to be a mark for going and subbing this in the first place. And then I think your other mark would be on simplifying correctly. So I would say probably an accuracy on that line over here. For this particular question or for this particular method over here, a mark on the answer, a mark on making the bases the same. There'd have to be a mark on rewriting root 3 as 3 to the power of a half. And then obviously your fourth mark was that one over there. Okay, good. Well done, everybody. You're all sending me through the correct answer for the nth term for 2.3. Lovely. Now you're going to do 2.3.2. Okay, so Tristan, your answer is different to Gugu's. It's different to Chesin's. Okay, so I think this might be one that we need to do on the board together. All right, so I'll come back and I'll definitely do this one with you. Let's just give everybody a chance to send through some answers. Yes, Lebogang, that's correct, but just be careful. You used the letter B and it should be an N. All right, and then there's never any need to plus or minus 0 onto other terms. It's not wrong, but it's just not necessary to write that, but you're quite right. Okay. All right, so for this answer over here, are you guys getting n squared plus n? All right, now, I'm very glad that you said that. So n is smaller than 30 or n is greater than negative 31. So now remember, we're talking about this not in the context of a function, but we're talking about this in the context of number patterns. So remember, if you are solving for n has to be a natural number. So it can't be negative and it can't be a fraction. It has to be a natural number. Okay, so Amatle, you're saying the same answer as Tristan. Let's have a look at this particular question. Okay, so I'm just going to scooch over just a little bit here. If you want me to show the full solution for 2.3.1, then let me know. Otherwise, I'm going to presume that everybody's okay with getting the nth term as n squared plus n. If you want me to show it, just let me know. All right, so now we've got n squared plus n, and then we're going to bring the 992 over. So that's going to be minus 992 is smaller than 0. You want me to show it? Oh, okay. All right. Sorry, guys. Just give me 1 second while I just show how we would do this. Okay, so I'm just going to scooch over just a little bit and just explain it quickly, and then we'll do that next question. All right, so those people that have asked me to show it, you've got 2, you've got 6, you've got 12, you've got 20, you've got 30. So you start by writing down your pattern and then working out your first differences. Remember, term 2 minus term 1, term 3 minus term 2, term 4 minus term 3, and in this case, term 5 minus term 4. There's your first differences. Now you find your second differences. Again, term 2 minus term 1. Your first differences are always a linear pattern. Your second differences are always constant for a quadratic pattern. Now we've got to use those rules. Okay, so we're going to take 2a and we're going to make it equal to our second difference. So a would be equal to 1. Then we're going to use 3a plus b, and we're going to make that equal to the first term in our first difference. So now we can sub in our 1, and that's why b would be equal to 1. And then we're going to do a plus b plus c equals the first term of our quadratic pattern. And that's why c would be equal to 0. So does it make sense now why Tn would be equal to n squared plus n squared plus 1n? You can take a snapshot of that or a screenshot if you want to. Yes. All right. Okay, cool. So now let's go back and go and solve this quadratic inequality. Okay. So when we are working with quadratic inequalities, it's not like a quadratic equation. So in order to work out the largest value of n, in this case, the first thing that we would need to do over here is we would need to factorize to get our critical values. So our critical values in this case are going to be, not that. Anybody get critical values here? Lebogang, you're not supposed to, yes, you're right, but you're not supposed to use the quadratic formula when you are working with, I suppose you could do it on the side in order to be able to work out what it was, but you're not supposed, you are supposed to be factorizing. Let me just see. So if you've got it was negative 32 and 31, that should work, isn't it? Yeah, that's it. Okay. So it would have to be inside here, it would have to be plus 32, and then there, that would have to be minus 31. So your critical values are where n is equal to negative 32 or where n is equal to 31. And now we would come along and we would draw what our pattern looks like, our parabola. There, so there's our x-axis, and there is our quadratic, okay? Our smaller number is on the left, our larger number is on the right. Now remember, as far as n is concerned, n cannot be a negative number. So here they're asking us to interpret this based off of the fact that this has to be smaller than 0. So in other words, it's got to be between here and here, right? 31 is not included, okay, because there's no smaller than or equal to. So it has to be the largest integer that's smaller than 31. So that's why it has to be it would have to be 30. Okay, so the largest value of n for which Tn is smaller than 992, the largest value of n is 30. Does that make sense to everybody? So this would be out of, okay, so Mamelo, you need to explain what you're saying no to. What do you not understand? Answer, factors, probably the diagram. Yeah, so it can't be 31 because Amatle, look here, this is just smaller than. Okay, so the largest value of n, your Tn is not equal to 992. It's smaller than 992. Okay, so it's not smaller than or equal to 992. It's just smaller than 992. So it can't be 31. This is exactly what I'm explaining, Mamelo. Okay, your Tn is smaller than 992. It's not smaller than or equal to. So we can't include 31. It has to be an integer, well, not an integer value, but a natural number, the largest natural number that is smaller than 31. So you're not supposed to include the 31 is correct, yes. Okay. All right. It's just smaller than, it's not smaller than or equal to. Okay, so we're not including the 31 in this case. Oh, Yolenda's here. Hello, Yolanda.
Not usually. Sorry, I'm late.
That's okay. Never
But I
mind.
made it.
Yeah, it's nice to have you here. We had Hugo standing in, but
Yeah.
it's obviously nice to have you back here with us again.
Yeah.
Okay. We've got 15 minutes left. I just want to see, I'm sure I had something else down here that was just a little bit more exciting. Okay, so you sub the 30 in. Okay, so if you sub in 30, you'd have 30 squared plus 30. Okay, is there something wrong with our factors then, Cheslin? Hold on a moment. Um, $29 squared. The factors aren't wrong. Oh no, we're correct. We're correct. Sorry, I'm being dyslexic. So I'm sorry. I was looking at 929 instead of 992. No, it's not incorrect because that's exactly what we want. You want our answer to be smaller than 992. So if you go 30 squared plus 30, you get 930. But if you went 31 squared plus 31, you'd get exactly 992. Okay, so that's why it has to be 30 and not 31. Yeah, that's exactly correct. Okay, all right. Sorry, I thought we'd made a mistake, but for a second there, but we haven't. Okay. What I'd like to do with you guys is this particular question just in the last few minutes that we've got. It's this particular question over here. And in this question, it gives us an arithmetic sequence and it goes 20, 23, 26, 29, all the way down to 101. The first thing that they want us to do Which of the previous question, Gugu? The second question. Okay. All right. Gugu, I tell you what, you could take a screenshot of that, and I can show you the answers to that the next time that we meet. Okay, I just want to show you guys this particular question. Okay, just so that we've done something that's a little bit more difficult and a little bit unusual. If we've got time, we can always come back to that other one, because this is a really cool question. Okay. All right, so the first thing that they want us to do is they want us to calculate the number of terms in the sequence. Okay, so that's not particularly difficult, right? We see that it's arithmetic, so we are going to use our Tn equals A plus N minus 1D formula. Okay, so what would Tn be equal to in this case? It would be the last term in the sequence. So remember, this number 101 is the nth term. A in this case is 20. And the difference between our terms is 3. So we'd end up with 101 equals 20 plus 3n minus 3. So I'm going to leave the 3n on this side, take the other terms over to the other side, and that would leave us with 84. So there would be 28 terms in this particular sequence. Now, the real reason why we are doing this question, they say to us, if the odd numbers are removed from the sequence, calculate the sum of the remaining terms. There's two different ways that we could do this particular question. Right, they want us to remove the odd number and calculate the sum of the remaining terms. So what do you think you would do in this particular question?
Let's go my checks. We have to remember.
So what do you think you would do, guys? If they told us they were taking the odd numbers out and we had to calculate the sum of the remaining terms, what would your approach be? Can anybody tell me what they think they'd do? Okay, so Nhlanhla says, okay, so Gugu, you're saying the same thing. So let's take out the odd numbers. So that gives us 20, 26. Obviously, if we added 3 onto 29, the next number would be 32, and so on it would go. All right, that's fine. So if you now want to calculate the sum of these numbers, you need to know how many numbers there are in the pattern. How are you going to do that? What's missing from here that I would still need? Ah, good, Gugu, well done. Okay, so this would go all the way down until we got to 98. Absolutely. So now what are you going to do, Gugu? Correct. We're not including any of the numbers that end in 1, 3, 5, 7, or 9. Yes, that's right, Cheslin. Why do we need this 98? We're going to find n. Okay, so we're going to sub into our nth term. So we'd have 98 equals a 20. Sorry, so 20 is a plus n minus 1. And our difference in this case would be 6. Cool. So we'd have 98 equals 20 plus 6n minus 6. So we'd end up here with 6n. And then as far as the 98 is concerned, that would end up being 84. So n would be equal to, okay. Now, we could have saved ourselves a little bit of time in terms of the solution over here, because if we look at the pattern, it starts on an even, and then it goes to odd, and then it goes to even, and then it goes to odd. And presumably then if it continues in this way, the next one would be even and then odd and then even and then odd. And then finally we end on an odd number. So if we started with an even and we end with an odd, and there are 28 terms in the pattern, it makes sense that half of them are even and half of them are odd. And half of 28 is indeed 14. Does that make sense to everybody? There you go. So we could have just divided the 28 by 2. That would have been okay for us to do that. That would have saved us a little bit of time. So now what we are doing is we are calculating a sum to 14. So 2 times 20 plus, let's just scooch over a little bit over here. And then here we would have our n minus 1 times our difference, which we now know is 6. Okay, does that make sense to everybody? Okay, and you should get 826 as your answer. That's it, Gugu. Well done. Perfect. Okay. The other way that you could have done this question if you wanted, Matrix, is you could have calculated the sum of, I suppose much longer, you could have calculated the total sum, then calculated the sum of the odd numbers, and then the difference between the two would be the sum of the even numbers. But it's much easier just to calculate the sum of the even numbers. Okay, if everybody's happy with that, let's just go up here. Gugu, you said that question 212 was showing you flames. So let's just see if we can quickly squeeze this question in before we move on. So it's an arithmetic sequence. So our difference.
Sorry. Is it
Yes,
fine if I
sorry.
run my poll?
Oh, yes, sorry.
No, it's fine. You can continue. It's just I run my poll at the background.
Yes, that's fine.
Okay.
That's fine. You keep on getting a decimal answer. Okay, so did you get a difference of -7 here? So these numbers keep getting smaller. And because we're taking away 7 every time. So if we want to write down the next two terms in the sequence, we would have -134 minus 7. So that would be -141. And then if you took away another 7, it would be -148. Now in 2.1.2, we've got Tn equals A plus N minus 1D. So A is equal to -113 plus N minus 1, and your difference is -7. All right, so expanding your brackets, you'd get -113 minus 7N plus 7. So you'd end up with -7N, and then -113 plus 7 would make it -106. That's what they were looking for. Okay, Gugu? Okay, so the general term in the form Tn equals Bn plus C. So when you are simplifying an nth term, guys, you cannot just leave it like this. You have to simplify. Okay, so you can't leave it as A plus N minus 1D. You've got to simplify it. So essentially B is -7 and Q is -106. Does that make more sense now, Gugu, and anybody else who had tried this particular question? Oh, okay, maybe you just weren't thinking about it. Okay, no wonder you ended up with a weird answer. And then, of course, calculating the sum of the first 50 terms of the sequence would be super straightforward because you're just going to use your arithmetic SN. So that would be 50 over 2 into 2A plus N minus 1, and your difference is -7. Okay. All right, guys. Well, if there's no more questions and you've answered the poll, you're more than welcome to log off, and we will see you next time.
Thursday.
Yes,
Yeah,
on Thursday.
Thursday.
We
Just
certainly
answer the
will.
poll for me, please. Answer the poll. Bye-bye.
Bye, everyone. See you next time.
There we go. It's 100%. Can take
Cool.
my screenshot. Okay, I got my screenshot. Bye, everyone.
Okay, so Cameron, there are 2 lessons at Watobe. There's one that starts at 5 and then another one that starts at 6. Okay, if you're still here. Okay, bye everybody.